We're on Kaggle, just a big repository with lots of data sets. So kaggle.com/datasets. And then this right here is the author. And then this is the name of the page. Okay, so data science salaries 2023. About the data set, this is very nice, this little card, where we say data science salaries has 11 columns, and it looks like they're named nicely. So work underscore year in lowercase, experience underscore level in lowercase, all the way down. The words in lowercase, and the word separator is an underscore. That's very good news for us, that everything's consistent. And then we know salary or work year, the year the salary was paid, experience level, the experience level. Okay, great. We know that the names of our fields are descriptive, and if we have specific questions, we can go to them. For instance, 5, 6, and 7, salary, salary currency, and salary in USD. It's nice to know here that salary is the gross salary paid, but it could be in dollars, or it could be in euros or pounds or whatever. The salary currency is giving us the country code, right? Like EUO or USA, depending on what type of money the salary was paid in, and then salary in USD. So they've gone ahead and just kind of converted everything to salary in USD for us. So likely what we're going to do here is go ahead and just drop the salary and salary currency fields for our uses, and only do salary in USD. And in any data set that you're working in, you do want to check and see if there are duplicates or near duplicates that should be removed when you're working on the data. So then we come down and we see DS for data science underscore salaries dot CSV. Okay, it looks very clean. The collaborators, again, we see the owner that we saw also up in the URL. And down here, we have some notebooks. So we see that there was a notebook provided to us by the owner that's going to give us some exploratory data analysis, or EDA. So we're going to download two things. One, the actual CSV. So we're going to download that, and we're just going to put it in our downloads for now. So save. And then we're also going to click on this EDA for data science salaries, copy and edit. And then we're going to bring it to our local machine. So file, download notebook. And we're also just going to leave it in the downloads folder for now. Obviously, if you're doing this and intending to actually do something with it, you should probably just create a new folder in one of your directories that will kind of put them both in the same folder. So we'll go ahead and save both of those. And let's open up the CSV first. So ds underscore salaries dot CSV. And this is just to make sure that we're looking at the same type of data that we were looking at on the kind of initial page. So work underscore year, experience underscore level, employment, job, salaries, remotes, company size, good. Everything looks to be quite clean and standardized. So this is obviously a data set that people have worked very hard on to make sure that it's very clean and ready for analysis for us. As we scroll through, we again just see that there aren't really missing values and that the data in each of the fields is pretty consistent. So that's a good sign for us. We just now got to be grateful for the owner for making sure that this data is nice and clean for us. Okay, now we're going to actually pull up the code. So EDA on data science salaries. I'm doing this in VS Code. You could do it in Jupyter Notebook or PyCharm or anywhere. I'm just doing it here. So I'm going to go ahead and we're going to load and import libraries, which includes this pip install country converter. I don't personally use this very often, but this is something, it's a library that we're going to use for a specific task. And so I'm going to go ahead and click install. Now and then I'm going to choose a Python environment. I'm just going to use my base Python environment for this. Now I've already installed country converter. So it'll say requirement already installed country converter, and then it'll give me the site, or it'll give me the location of where I have that library. And then same thing about pandas, numpy, and everything else. And then it says a new version of pip is available, and I'm going to go ahead and just ignore that for now. So now we're going to go ahead and look at these libraries that we import, because the libraries we import tell us a lot about the type of data that we're dealing with and what we're trying to do with the data. So we import pandas. Pandas stands for panel data as PD. So whenever we make a call to the pandas library, we're going to use PD. Panel data is just what it sounds like. It's when we have rows and columns in some sort of spreadsheet, and we want to read in the data as a data frame, which is like a Python version of a spreadsheet, and then we're going to do manipulations. So all the same type of manipulations that you could imagine doing in Excel, you can do with pandas. So pandas as PD. NumPy, that stands for numeric Python, and it just helps us deal with arrays and math operations. There's also a math library, but NumPy is one of just the very common ones for basic operations, and whenever we use it, we'll refer to it as NP. Country converter, again, that's probably doing some sort of conversion with those country codes in that field. That's what we can assume, and we're going to refer to it as COCO. These libraries, matplotlib as PLT, Seaborn, Plotly Express, down to Plotly Figure, these are all plotting libraries. And so matplotlib is kind of the base Python plotting library. And then Seaborn and Plotly Express are libraries that are built on top of matplotlib that allow you to do just more beautiful plotting. So all the same functionality for the most part, but they just look prettier and more presentable. And then there's word cloud. So from word cloud, import word cloud. This from statement, rather than as you can see here, we're just importing the whole library. And with large libraries, that can take some time and use some space. In theory, in reality, it doesn't come up very often. And then from word cloud, import word cloud is saying, okay, we have word cloud installed, and we don't want to import the whole library. We just want to import a specific method or module. So we're just basically, rather than saying we want the whole library, we just want a book or a set of books. But we're not going to use word clouds, so I'm just going to go ahead and delete that. And then import warnings, and we're going to ignore warnings, and then import NLTK, which is Natural Language Toolkit. That's used for kind of just what it sounds like, for dealing with natural language, either in prepping data for machine learning tasks or in whatever the owner has in store for us down below. And then this line right here, matplotlib inline, is just saying we want to see plots right beneath the cell, the Jupyter cell. So I'm going to go ahead and run this. We'll get our time down here, and we get a check mark that says, great, we got it. One thing that can happen is you can run this cell, and again, it's good practice to hold all your import statements in a single cell or just all together and run them at the same time. You could get an error, like actually if I go ahead and put back in from word cloud, import word cloud, and then I try and run this code again, I'm going to get a module not found error. This module not found error is saying I haven't installed a package, and it will point here to the package that I haven't installed. So I haven't installed word cloud, and then it'll say again, no module named word cloud. If you need to install a package, you actually just do exactly what is shown in this cell up here, where you do pip install. You could also use conda install if you're using a conda environment, but in our case, pip install, and then the name of the library. So we would do pip install word cloud, all lowercase, and this exclamation mark here just said we want to run it in the terminal. But again, we're not going to do that here because we're just not going to do word clouds. Okay, and then we're just going to go ahead and read in this data. So df stands for data frame equals pd, so pandas dot read CSV, and then we get a string. So this is just saying we want to create a data frame, which is like a Python version of a spreadsheet, and we're going to build it by calling to the pandas library with the method that's this dot right here. So we're calling the pandas library PD, and we're calling a method, so a specific function inside that library using the dot, and that method is read CSV, and then we pass an argument. The argument is the string, the location of our data, and if we run this data, we will actually get an error. It'll be a file error because we don't have this path that the author had. We actually should only provide the ds salaries .csv. But we're going to go ahead and run this code just to show the error that we get. We get a file not found error, and again it points us to the line where we get this file not found error, and then down at the bottom we say no such file or directory. So again, that's telling us something we already knew. We're going to go ahead and delete the parts of the file path that we don't have, and we're just going to pass ds underscore salaries dot csv to it. And again, we could pass a long name, we could pass the full name to it, so that we can always get the CSV no matter where our code is located relative to our CSV. But in this case, we're just going to pass the CSV under the assumption that the CSV and the code will be located in the same directory. And then this right here, df, so data frame, calling the method drop, which is just going to remove whatever we pass to it. Df, so data frame, salary, salary currency. So this little bit of code here is saying we want the data frame to drop 2 columns in the data frame. And we pass those columns as strings in this list, right? This is a list with 2 brackets around it. So strings in a list inside 2 brackets. And that's just kind of the syntax that's required, and you can look that up in the documentation. So now we're going to go ahead and run this code. It should work for us. Great, it worked for us. And now we're going to go ahead and print the shape. So from data frame dot shape is going to give us the number of rows and the number of columns in our data, and df data frame dot head is going to give us the first 5 rows. And there we have it. So 3755 columns, 9 rows because we dropped 2 of the original 11. And then we have the first 5 rows, noting that we index from 0. So we have 0, 1, 2, 3, 4. We have 9 columns, and everything looks good. So now that we have read in the data as a pandas data frame, Python can interact with this data kind of directly. Last thing we're going to do here is just sum all the null values in the data frame. So this right here is saying we want to deal with our data frame, and we want to use the method isNull, which is just a Boolean saying yes, there is null, nothing, empty in that cell. So like if this ML engineer under job title was just an empty string, we could say df.isNull and then pass job title, and it would give us that there's that this right here is null. And if we say sum, then we would get 1 null value. But in this case, there are no null values in the entire data frame, again showing us that we have a nice clean data set that someone has worked very hard on.